let's talk about the origin of amino acids. Or for that matter, you could argue to some extent the origin of life. Now, the argument was, where in the world do amino acids come from, right? And you could say, oh, it's vitalism. It's some fundamental life force that some active creator specifically made. And maybe that's true. But a graduate student named Stanley Miller was working in Harold Urey's lab at the University of Chicago in 1953, and he was really curious about what conditions were like on the primitive Earth. And so they built an apparatus that looked like this. It was a pretty cool apparatus. So he had a flask here, and this comes off down here. He's got a little gas inlet sampling, gas inlet. Okay. And then this thing goes into a beaker like this that you could sample from. Great big beaker. Okay. Flame underneath it. Okay. And it had two things in it. This had a solution in it that was composed of the kind of stuff you might expect to find on the primitive Earth. It had H2O in it, it had ammonia in it, it had methane in it, and it had hydrogen gas. The kind of stuff that you might expect would have been there, right, on the primitive Earth. And as I said, he lit a little flame underneath this, and then he did one other thing that was pretty cool. He knew that there was a lot of lightning on the Earth back then, and so he set up some electrodes so that there were sparks. Okay? So he could make sparks in this atmosphere. So you've got water, ammonia, methane, and hydrogen, stuff we already think existed on the primitive Earth. And you keep zapping it. You boil it down here, and you zap it with electric sparks up here. Oh, importantly, he had a condenser in here, too. I got to mention that. Okay, so he had a nice condenser. So H2O goes in here, circles, comes back out here. Condenser, I'll draw it in blue. Condenser. Okay? So that the gas got condensed back into liquid down here, right? And then it would evaporate up here like a primitive atmosphere, get lightning, the equivalent of lightning with the spark, condense into a liquid again. And he just let this thing circle and cycle and cycle, okay? And after 1 week of doing this, he took a needle and he stuck it down in here. Here's his needle. And he sampled what had happened from this ammonia, water, methane, and H2 that were circling here in this primitive Earth atmosphere. And after 1 week, in fact, what he found was a whole lot of organic compounds. He had 13 out of the 20 amino acids that he could detect here. Now, interestingly, it was a 50-50 mixture of the L and D forms, and you know that most proteins, all proteins that we know of are built of what kind of amino acids? L or D? L amino acids. Interestingly, he also found, besides these amino acids, nucleotides had been formed, simple sugars had been formed, okay, etc. Now, that would suggest that it's possible that without any divine intervention at all, just the existence of an atmosphere that contained water, ammonia, methane, and hydrogen, together with a spark and some flame, you could end up with all of the chemical constituents that you would need for life. Now, people said, well, how do you know? Maybe, this is something done in a lab. How do we know there's any truth to this? And in fact, a couple of years after this experiment was done, there was a meteorite that struck Murchison, Australia. Okay? And they could find in the center of that meteorite, they were able to find in the center of that meteorite some ice. And so they took that ice and they thawed it and they looked at what was in that liquid, and guess what they found? The same number of amino acids in the exact same proportion as what Stanley Miller had created in Harold Urey's lab. And this meteorite, right, has been out in deep space for a long time. So this is, I think, a convincing argument that all of the conditions necessary to form the chemicals from which life is created can exist simply from a primitive atmosphere in the presence of enough electricity.